So here's the final product of today's video. It's going to be a long one. People say that I've skipped some of the important steps, and that's kind of true. I didn't think I needed to cover every step of the alignment and so forth. Hey, come here. Ah, yep, I know. Don't go down there. So I decided on this video I would just cover everything, and it's long. It's about an hour and a half. But on this one, I'm going to go through the alignment process. I'm going to do some troubleshooting. Going to hit some quicksand, big time. But that's where the learning happens, and so I think it's fun. So you can skip around. I'll put some chapter markers in here this time, and hope it helps. That's what it's for, trying to help you guys just as others have helped me. So let's go. And no, this is not an HW-101. That seems to be all I've been working on lately. No, this is a Heathkit SB-102 transceiver. Someone asked me if I had any available, and I went through the archives, i.e. my guest room, my dining room, everywhere I had a spare rig, and I found this one. It was hiding from me because it didn't have the escutcheon with the model number on it, but I know it's an SB-102 because it's got the solid state LMO. This is one of my favorite SB rigs, mainly because of the LMO. I do like that drift-free solid state LMO. It's got the CW filter, which makes us happy, and it looks like it was very well put together, so that's good. I'm going to fire it up, see what happens. Okay, all wired up. I don't have any way to turn this, to tune this, except with my finger. We're not getting any ALC deflection. That's not good. Let's go ahead and all right. The purpose of this is just to kind of see how much work we've got cut out for us. You know, obviously I have not cleaned the wafer switches. You know, I don't always expect it to fire up, but a lot of times they will crackle and sputter, and believe it or not, you can hear a signal coming through. And this one is not giving us that. It is giving us some hum, but I wonder if everything is seated. This is usually, sometimes, oh, we have no product detector. Oops. Take two. Gotta have your product detector. All right. Still not getting, well, meter's working. Yeah, okay. Well, all right. We know she works. Let's hook up an antenna, see if we got a signal. All right, it's got the old RCA jack on there. We're gonna deal with that later. Give it an SO239. Listen to that. We're at 20 meters. I'm still a little concerned about that.
Good evening. Thank you for your call. You are 5 minutes +5. Back to you, colleague.
Makes me really happy to hear that nice, warm signal coming through. Wait, this is the second time in a week that I've seen a wire wound resistor with discoloration on just one end, just like that. Look at that. Last week, I had the same problem. And I know this resistor works, but why is it discolored? If you know, look me up on QRZ and send me an email. I'm very curious. I got all the knobs off, and now I'm stripping down the RF cage. I want full access to every compartment of this radio, because once the water starts to pour, I want to be sure this thing is opened up enough so it fully dries out. It's very important. People ask me, like, if you had the choice between an HW101 and an SB-102, what would you choose? And you know, I'll tell you this, the SB line rigs have some advantages. For one thing, I like the cabinets on the SB rigs. The lid raises up, you can get in there, you can make your adjustments. Like there's a side tone adjustment. This does not exist on the HW101. The cabinet of the HW101 is rather difficult to get in and out of. However, oh yeah, and this has got the solid state VFO, so there's no drift. However, the HW101 has a really nice tuning mechanism. And I've worked on enough of these SB rigs to really come to fear that tuning mechanism, because all the plastic in here is very, very fragile. The dial has a tendency to crack. It's got the little fine tuning adjustment, and that pulley has to sit right on the edge of this window, and every one of these windows has some deterioration right there where the pulley used to be. And so you've got to like rebuild that plastic with glue or something, and a lot of times the fine-tune adjustment will not adjust. I don't like this. Okay, I don't. I mean, it's clever. I know it's meant to kind of simulate the Collins line, but I don't know. I really prefer the HW101 tuning. So that's just me. So you have to be very, very careful removing these finals. I was easing it out. I was gently rocking it back and forth, pulling up on it, and I heard the dreaded crack. And that is the little plastic registration stub on the bottom. It broke off. Well, guess what? It happened again. Damn. I think that there had been so much heat, and these finals have probably never been removed, that the plastic just basically fused into the socket. So that's the way it goes, but we're going to save them. And to get them out, you just go to the underside of the tube socket and just pop it up. So you can see where the plastic corresponds. It just kind of fits nicely right in there. So I'm going to glue that back on, knowing that once I get that tube in the socket, next time I pull it out, there's a very good chance this thing's going to break off again. But the main thing is I want to make sure my tube pins are oriented correctly, and I think that's the way to do it. So our goal with the sink scrub is not to create a museum piece, but to create a clean working environment. And man, this is dirty. I've seen people go in here with a Q-tip and alcohol. No way. No. I don't do it that way. I've seen people put them in the dishwasher. Problem with that is you got to really get in and scrub with a brush, or a lot of this baked on grit's not going to come out. So all my knobs have been removed. I've got this thing positioned. I've got this positioned so that the water is moving downhill from the LMO. I don't want any water getting in here, because I'm going to have to dry it out thoroughly. And I do not want any residue trapped inside. plain old dish soap. I'm going to start out with a floppy paintbrush. Again, we want to start out by just getting any moving debris out of there. And I'll go back in there with a smaller artist paintbrush and get between the components to get some of that baked on stuff out. And now, let's rinse it off and see where we're at. I got this process from a Heath engineer. And if you can't trust the Heathkit engineer, who are you going to trust? I've never had any problems with this method at all. So now you can see the results of step one. The larger areas of the board are nice and clean. The areas between the components are gritty, really gritty. And so I'm gonna go back. Man, it's like tar, wow. You know what I'm gonna do? Oh man, that's not gonna come off with soap. I'm gonna have to get some gunk remover. This is what I use. I find that it does not cause the silk screen to fade. It seems to be pretty tough on grit and not tough on silk screening. That's important. So I'm just gonna spray it wherever I see grit. And that grit is baked on because those tubes are so damn hot, So this will help get that stuff off of there. Now I'm just gonna go through with a smaller paintbrush and do some of the close detail work. This whole process takes about 15 minutes. It's not all that involved. Like I said, my goal is not to make anyone think this is a brand new transceiver. These transceivers were made between 1970 and 1975. They're old, but they clean up really nicely. And you can see how all that grit coming up and discoloring the solution. So this is gonna really look nice when we're done with it. One more rinse. Just look at that crap coming off of those boards. Wow. A lot better, but I still see some grit and I want to take care of that. I'm going to get a smaller paintbrush, but overall, yeah, much better. Ooh, yeah, you'll find on the audio board between these two tubes, that's one of the most challenging areas for grit. Well, there it is. I went through a couple times, scrub, rinse, scrub, rinse, scrub, rinse. And I think the results are pretty nice. We do have some residue still between the components here on the audio board. At this point, the only way I'm gonna get this any cleaner is if I start removing components and then scrub the board when it's free of obstruction. I'm not gonna do that. Once this dries, you're really not going to see the grit here, and it doesn't affect performance. So very happy with it overall. I'm going to set it on, this is about 150, 170 if you have that setting on your oven. Put it in for 30 and then let it sit for 30 with the oven off. While that's baking, give my knobs a little bit of a cleanup. That's where a toothbrush comes in handy. If you have knobs that come out this clean, count yourself lucky. And there's the net result of the sink scrub. Wow. I just love how nicely these boards clean up. If you aim the light just right, you'll still see some of the grunge on the audio board. But you know what? If it's that important to you, then pull these caps, pull that resistor, get in there with a brush and clean it out, because you can do it. But now what we need to do is check all the resistors. And I use these check sheets just as an easy way to check off which ones need to be replaced. I replace those that are about 18% over their value. Remember that resistors go up in value when they age, especially these carbon composition resistors. I'm going to guess we'll probably find about a dozen bad ones. And I'm also going to pull that paper cap. I'm going to pull that paper cap. I'm going to pull this electrolytic. And yeah, but step one, let's check every resistor, and there's over 100 of them. By the way, I'll put a link to these check sheets on the description of this video. Oh yeah, I need to point something out. I made these sheets for the Heathkit SB-101. It's just an easy way to quickly check off where you need to replace a resistor. However, the SB rigs have slightly different values here and there. I would say these are about 95% the same, but every now and then you'll stumble across one that's different, and so you just got to be aware of that. Let me show you an example. Check this out. On the bandpass board, we've got resistor, 2 resistors, capacitor, resistor. On the HW101, you have 2 resistors, capacitor, and nothing. You have a crystal socket here. You do not have one on the HW101. So there are some places where you do have some slight differences, but for the most part, the resistors are pretty much the same. Well, I was wrong. There were 20 bad resistors, and they've all been replaced. Took about an hour and a half to, maybe like 2 hours to identify the bad ones, pull them, and replace. I just unscrewed the top of the LMO because I'm really eager to see the condition of these electrolytic capacitors. If these capacitors are not both good, you'll have some very troubling audio. I know my audio is good on this rig because I've already heard it, but if those capacitors are weak or looking like they might be reaching the end of their lifespan, I am going to replace them. I may just replace them anyway. So using my ESR meter, I checked both of them and they're both testing good. So you know what? I'm going to replace them anyway, because one day they're going to go bad. To get access to those caps, I'm going to clip off these 2 wires. Okay, 500 microfarads at 25 volts. I've got some of those. And there they are, the new electrolytic capacitors. And I found something interesting. Look at that, November 24th, 1981. These rigs were only in production until 1975. What does that mean? So I see that there is a service sticker. So did the rig get a new LMO in 1981 or 82? Kind of curious. Was TRW still making these things in 1981? It's weird. I don't know. Mystery. We've got some new balanced modulator diodes, those blue ones there. Those replace the germanium diodes that were there before. Those are 1N5711 Schottkys. There's 4 of them. And those are critical diodes, and they're prone to failure. So I replace them. Probably nothing wrong with the ones that were in there, but we want to make this last. Tubes are all populated. It's looking like a real rig now. Time now to install the finals. It's been a day. That glue has set nicely, and these feel really solidly attached now, so I think they're going to work. All right, obviously we have the front panel to deal with, but I'd like to just see what happens when we fire it up. Okay, the moment of truth. Okay, meter's deflecting now. That's good. Uh-oh. Uh-oh. All right. we should just turn that off. Okay, well, that to me is a problem on the audio board, and my first line of assault is going to be looking at wherever I pulled a resistor, wherever I did any kind of work, because there's a very good chance that I screwed up somewhere. It could be a solder bridge. Sometimes you pull a resistor and then you forget to put one back. And who knows? Let's go see. I indicated on the X-ray view where I pulled resistors. And so I'm going to go through and just inspect all my traces and see. Well, still on the audio board, and I think it's this guy right here. Yep. In fact, I know it is. That did not get properly soldered. That's a hard place to solder, by the way. It's right next to the chassis, which creates a kind of heat sink. Or sometimes I will actually loosen the board all around the place where I want to solder, drop the board just a little bit so that it's not making contact with the chassis, solder it, and then retighten the board. Anyway, let's get at that trouble spot right there. That's our culprit. Before we go any further, it's time to clean all the wafer switches. Remove any possible buildup, any crusty stuff on those switches. Got to get it off here. Also, I'm going to hit all my potentiometers with contact cleaner. Just want to get any grit out of there so that they're not scratchy. The mode switch, that's really important to get clean. And by the way, I'm just using this stuff that I got at the local hardware store. My variable capacitors, want to get any dust out of there. Back we go, 3, 2, 1. See, that's not enough meter deflection. We've got another problem in there somewhere, but this damn thing should be pegging and then coming back. Anyway, I hope our squall is gone. Oh yeah. Good, good, good. See, we are not getting enough. RF gain fully counterclockwise, this thing should be pegging to the right, and it's not. Okay, antenna's connected.
Listen, I won't keep it. I just wanted to make sure everything was okay on the radio now that I got things back home. We had some heavy winds here in our area. We're right on the west coast near Sarasota. And anyways, let me say 73 for now, and I'm going to go check with my wife and see if everything else is here at the condo. By the way, we're in a 10-story condo on the 10th floor in the right here.
I do not like adjusting this
Okay, I think the other one was
ALC
slightly
pot.
stronger, but this one here, you're right about 5'9", but back to the other one, I'll give you a little.
Let's see if we can get a little more off of that meter. No, not getting anything at all.
I think the vertical is maybe 5.
I'm going to go ahead and swap out these two, V3 and V4. Put in some new 6AU6s. Sometimes that wakes it up. All right, I replaced those two tubes.
That new vertical that I rigged up there and put the radials on and for it. So we'll try that little vertical with the elevator radial and see what happens.
And we got nothing on that.
It's been on for a couple of weeks now.
Nothing. One good thing is that now the RF gain is deflecting as it should, so we know to look at V3 and V4 next time this happens. But I've got the calibrator on, and I've got basically negative deflection on the meter. And when I adjust the ALC pot, nothing happens. So, by the way, that's a terrible place to put an ALC adjustment. What I often do with these rigs is I will include a nut starter and just leave it in there so that the buyer or the owner of the rig can easily adjust. Because you have to do this when you switch bands. And how are you going to get in there with all those hot tubes? And if you don't have a nut starter, there's no way. You just can't do it. Anyway, let's figure out what's going on with this ALC. So we know that the metering circuit for the automatic level control is right down here. See those 3 new resistors? Okay, those are new. And we know that tube V3 is okay because we're getting meter deflection. So what the heck's going on? Okay, step 1, I'm checking this 200 ohm control. Got 250-ish. That's 25% high, but that should not stop the meter from operating. So we got something else in there. When in doubt, consult the manual. So we read that the ALC voltage runs through, let's see, where does it run through? Runs through here. Well, stop the presses. I was twiddling with this 200 ohm potentiometer again, and guess what? The damn thing came alive. Look at that. It's moving now. And as I play with it, I notice the needle is jumping around. So what that tells me is that potentiometer needs to be cleaned. So I'm going to flood that out with contact cleaner. I'm going to get that side tone adjust pot as well. And then I'm going to flood these 3 with the rig off, of course. But yeah, I'm gonna have to keep my eye on that thing because these for some reason these 200 potentiometers, that one and this one, have a tendency to degrade, and I don't know what it is about them, but they may end up getting replaced. If I replace this one, I'm going to put it up over here because this is I'm sorry, Heathkit, that's just a dumb place to put an adjustment that you use all the time. So anyway, let's flood it, see if cleaning it helps. So based on what's happening with that potentiometer, I'm gonna go ahead and pull this one out and replace it with a 20 turn pot. Question, why not replace both of them? Well, because you can't put a 20 turn pot down there. It just doesn't work. And this one is mission critical. If this one fails, we lose all output. If this one fails, we don't get an ALC reading on the meter. But this one, we have to have it working and working well. So I'm going to pull it. It's a little tricky getting these out. I'm going to heat up the 3 pins, raise the legs, and apply heat on the side, see if I can get that out of there. Sometimes I just pull out these 3 legs and just leave it in there, and then install my 20 turn pot right next to it. So I'm going to use my trusty dental pick, just heat up the base of the foot there, or the leg, pull it out. Sometimes you'll see these with a wire going over the top, and that wire goes down and grounds it to the board. But let's see, oh, that's going to be a lot easier than I thought. These dental picks are super duper helpful. I've got a whole collection of them. Actually, I go to my dentist twice a year, and he knows I like dental picks, so he's always got a nice assortment for me. There we go. These are my favorite needle nose pliers. When I started doing restorations, I was walking down the sidewalk and I found this lying in the ditch, almost left there by the Heathkit Guardian Angel. There we go. Now I'm gonna just clean up some of this solder so I can go in and install my 20-turn pot. This is a 20-turn 200 ohm potentiometer, basically an adjustable resistor. Normally, you want that screw to be on the top so that when you install it, you can just put your screwdriver down and adjust it when you're nulling the carrier. I got these by mistake long ago, and I'm out of the ones that have the screw on the top. So I'm going to install this on the underside of the board where I can adjust it from the side. And so with the screw facing this way, I'll be able to just reach in there with a long screwdriver and adjust it when I null the carrier. So there it is. And when I'm adjusting the carrier, when I'm nulling it, I'll be able to just turn it like that. I think that's actually more convenient than trying to do it on the other side. We will see when we get to that point in the restoration. We have 2 relays on this rig, and there's a very good chance that these relays have never been cleaned. So there may be half a century of gunk. So what I do is take a sheet of just a little slip of plain old bond paper, spray it with contact cleaner, and then just run it back and forth between the contacts. No sandpaper, no, really aggressive cleaning necessary. These contacts may have a little bit of debris built up. I don't see anything on these, so that one's okay. By the way, I just love SB rigs for the fact that these relays will pop in and out. You can't do that on the HW101. They're hardwired. Here's the other relay. Same deal. We're going to get a slip of paper between those contacts, get it wet with contact cleaner, and run it through. So we're getting now to the more nuanced jobs. I kind of am not all that happy with these tarnished, oxidized tuning shafts. They're kind of gross. Let's take them off and let's make them shine again. Okay, this is the shaft that controls the 2 variable capacitors on the finals. It's this inside one has got to move freely, and it's got grease in there dating back to about 1972. So we're going to clean that up by just shooting some contact cleaner right through there, and take the shaft and just move it up and down, free up that old grease. And I'm going to give it another shot under the desk. All right. And one more of these. And now this is all wet, so I'm going to clean this off with a rag, get any remaining grease off of there. One more shot. Okay. You really want these to turn independently. Otherwise, you'll be adjusting your finals, and that little thumb switch will start turning when you turn the inside knob. And so that's why we want these guys to move independently. All right, little 3-in-1 oil, just 2 drops into that shaft. Running out of my 3-in-1 oil. There we go. Okay, next, I've got this thing on the end of my drill. I've got some Brasso. I'm going to put it on a rag and watch what happens. Look at that. Pretty sweet. Now we've got our pre-selector shaft, and it does not respond quite as easily to Brasso. So here's what we're going to do with that. Got us some fine sandpaper here. This is, what is it? I think this is a 200 grit. It's an old piece, so it's kind of soft. I don't want anything super coarse. I don't want to leave a lot of striations. I really just want to get that tarnished metal shining again. Here we go. There's your before and after. Pretty impressive. Cut that sandpaper down a bit. Just get it between these pulleys. I am not going to remove these pulleys. These are soldered down. Once they're soldered, leave them. And if you want to get really in there, you can do the back side of the pulleys. And fully installed. Big difference. By the way, I wonder if we can get that off of there. Obviously some quality control person, maybe a little acetone. That did it. By the way, I had to remove the 6146 tube while I was installing the shaft, and the pin on the bottom of this thing is really holding up nicely. That glue is solid, so I don't think there's going to be much chance of this thing breaking off anytime soon. All right, time to deal with this. And guess what? It's not going to be that difficult. We don't have to pull the front panel off to get that dowel drive pulley on there and the fine tuning adjustment and the escutcheon. We can get them all on there. I just basically pop that escutcheon in place. I somehow happen to have one of these in my parts box. Man, that was a stroke of luck. If you need an escutcheon, you can get them on eBay. If you have one that doesn't have the right model number, you can get just this label. Actually, it's a set. It's this label and a label that goes here. And that's $5 plus shipping on eBay from Mahoney's Radio. So that's a good product. And I've actually used those because yeah, if you don't have the right model number, I'm not going to put an SB-400 escutcheon on there, So I cannibalized a parts rig to get the other stuff that we're going to need. This is the fine tuning adjust pulley. And so what are we going to do? All right, this is the dowel drive pulley, and it was really sticky, so I sprayed contact cleaner on there, put it on the end of my drill, squeeze this, start up the drill so this thing's spinning like crazy with contact cleaner on there, and that really cleans that out well. So it's spinning nicely now, but I'm still going to lube it up a bit. To get the escutcheon in place, it's got these clips at the top, and this rectangular form here has to fit inside this cutout. All right, that's not quite as easy as we would hope. I'm going to go ahead and get the fine tune adjust pulley mounted like that right in the corner. This has to be mounted first, okay? That's got to be in there, and we're going to finger tighten it. Okay, I've got that. I want it to be in the up position. Then I'm going to get it. I'm going to get that pulley right over this hump here, like so. Okay, that's done. And now I'm going to get the fine tune adjust shaft like that. And now these clips at the top, I'm going to get that in there and then shove it upward. The goal being to get this rectangular form to go inside the cutout. Sometimes that's more easily said than done, because you really got to apply a lot of upward pressure. There we go. All right. So, yeah, make sure that this didn't hop out, and I see that it's still grabbing. It's moving that fine tune adjust pointer. This requires a very fine Allen wrench. And now all the knobs are in place. Got the escutcheon on, got the fine tune adjustment in place. Now I want to just adjust this, and I'm going to show you my technique for making sure this thing doesn't slip. So remember how we had this dial drive pulley shaft in the up position to get the escutcheon on? Well, now I've got it loosened. It goes up and down, and it goes in and out when it's in the up position. There's a pulley on there that needs to grab onto the ring of the dial. That pulley needs to bite right into this metal ring, okay? So right now when it's in the up position, that thing is going in and out right there. When it goes down, we want to be able to get it so that the pulley drops and clamps right onto that ring, all right? So to find it, I've got this thing pushed all the way in. I drop it, and I'm going to pull it out, raise it up until I can feel it going over the edge of that ring, and then drop it back down again. And now it's turning. So I want to get this thing tight enough so that it doesn't slip. The problem we have sometimes with these is that you think it's on tight, and then you're turning the knob, and then suddenly, oops, nothing's happening. So the way to do that is to take a flathead screwdriver and push downward on this washer, okay? Here's the thing. You don't want to do it so hard that the thing doesn't want to turn, or so weak that it just turns freely and the dial doesn't turn. So I've got it in there. I think that's pretty good. Holding pressure, I'm just going to go ahead and tighten that nut. Again, I don't have too much pressure on it, but just enough so that it knows that it needs to stay on that ring. I think it's going to work. Let me put the knob back on. Dial is turning nicely. It's a little stiffer than I'm used to, but I think it's going to loosen up a bit as time goes on. I don't want to start with this thing too loose and then it starts slipping. I think this is just perfect. And again, we have our fine tune adjustment working. And I think it's time to start doing some aligning. One of our knobs is missing the metal insert. That annoys me, but I've got these. They're from K3ICH, and he has them cut exactly the right size. And wow, it's amazing that there's somebody out there who actually makes these things. K3ICH. Also, I'm getting tired of looking at that. Looks like there was a piece of tape there at one time. Let's get some acetone on that. Okay, that looks a lot better. So who likes phono jack antenna connections? Well, I don't. And I think I've got something that'll go really nicely there. When we think of an SO239, we think of one of these, right? They're big and clunky. Requires 4 screws to hold the body to the chassis. Most people only do 2 screws. I'm not a big fan of these. I like these. You drill one hole, it goes right in that hole. You get your ground connection right through the body of the SO239. No additional holes necessary. And it's pretty easy to install. You just desolder this wire going to the center pin, and then if there's a chassis ground, I'm sure there is one, isn't there? I don't see one. Well, anyway, let's get that wire desoldered, remove this, and then drill it. And of course, to drill the hole, you'll need one of these. Home Depot, 10 bucks. This is me trying to solder, holding the phone in one hand and the soldering iron in the other. That's weird. There was nothing grounding this. Well, I guess the body of the socket was grounding it, but Usually there's a wire going from the ground side of the socket to like an auxiliary point on the chassis, like a solder lug. That's weird. Let's look at the instructions. Okay, this is an HW101 phono jack antenna socket, and see how on the left the ground side of the socket goes to the relay? That's weird. But you know what? I'm looking at the instructions for an SB-101, and it's basically the same as a 102. And I don't see anything going to the ground side of the socket. You know what? I'm going to go ahead and ground it, because why not? You know, nothing wrong with more ground. Our barrel type socket does have this tab. By the way, did you know that people used to put their social security numbers on their radios? I'm going to cover part of that up. I mean, he's probably gone by now, but isn't that weird? So, got to be a little careful. There's a lot going on in here, and as we drill, baby drill, this is going to possibly make contact with some of this stuff if we're not careful. So, you want to go off topic for a second? So it's March. This is Novice Rig Roundup, and it's a chance for people to get out their old novice rigs and blow the dust off of them and have QSOs, and it's kind of a competition as well. Well, most people, when they think of novice rigs, they think of something like that, you know, something from the early 60s. This is from the 80s. It's 50 watts. And, oh, sorry, I was right on top of you. 50 watts, solid state, 100%. Very simple. Very simple. It's CW only. And I have such a good time running this rig. I actually built this as a kit and had to get it fixed because it's very drifty. But it's a really fun little radio to use. Oh, here's somebody. Yep, NRR, that's Novice Rig Roundup. Love this rig. Okay, let's get back to drilling holes. Comes with this nice ring, which is kind of handy because that covers up those two screw holes on the outer edge of the hole. Look at that. I mean, voila, wow, isn't that nice? Okay, so on the inside, I'm going to insert this this ring with the ground tab on it and the nut and get them tight. All right, that's the wire going to the center pin. I'm going to solder that. And then my ground lug is at the top. I'm going to attach a solder lug to this chassis screw here, and I'm going to connect those because I want to have a really good grounded chassis for that antenna. There's the final product, and what I ended up doing was just taking these two lugs and soldering them together. We've got a really good ground contact now. Just look at that. Way better than that, I think. Just my opinion. You know, I don't usually show the alignment process on these videos, but I feel like doing it today. So let's just do a basic receiver alignment. Start out, and I'm going to do it fast, okay? Start out on 80 meters, 3.5. Got your tuner at around the 200 mark. Set for ALC, go to calibrate. Adjust for peak. All right. Got to have an alignment tool for this. If you don't, I sell them on eBay. We're going to start with transformer T201, and I'm just going to go for a peak. All right. Now I'm going to go to T102. This one, don't touch it. That's factory adjusted. In fact, I'm probably going to put a piece of aluminum tape on top of it. This one has a top slug and a bottom slug. So I'm going to do the top slug first. I feel like these transformers are already peaked with the previous owner. Okay, do the top, the bottom, and then go back and do the top one again. And now I'm going to go to this transformer, looking for a peak. All right, we're peaked. Okay, I've got the rig flipped on its side, and this looks like there's some old tape over these coil openings. I don't know why. I may get after that with some gunk remover in a bit. Anyway, let's stay on topic. So I'm still in calibrate, and now I'm going to do these two coils. And by the way, at this point, the driver pre-selector is critical. The positioning has to be exactly right. So I'm going to make sure that this is, for 80 meters, it needs to be right at 12 o'clock, okay? So I'm going to peak this, watch my meter. Okay, now this side. The manual gives the steps involved. These have to be aligned in order, okay? We go from 80 meters to 10 meters, 29.0, and now the pre-selector goes right to that point. And now we have to find the calibrator signal again. Sometimes it's very faint on 10 meters. I don't know why. Okay, that's a harmonic. If it's the same pitch on every band, that's not really the calibrator. This is not going to be a good case study because we don't have a good calibrator tone on 29 megahertz. Ugh, God. Let's peak the heterodyne oscillator coil and see if that gives us... Oh, listen to that. Did you hear what happened? The heterodyne oscillator coil was just slightly off. And so we weren't getting any voltage on that band. I'll go through that in just a second. Okay, sometimes this happens. It means your slug is stuck. For that, I have some of these. Don't worry, you're not going to get electrocuted on these particular adjustments. Okay. All right, so heterodyne oscillator coil is where it needs to be. Again, I'm going to go through that in just a sec. Let's see if we can get some... Oh, yeah. All right. Now I'm going to go for a peak. That's really low. And don't worry that it's not 20 over S9 or whatever. Just get it to peak. Now we go to 21 megahertz. So that's 1, 2, 3 stops. And now the pre-selector goes to that position. Okay? Important. All right, let's see if we can find the calibrator. And once again, I'm only hearing the harmonic. What does that mean? Well, remember what we did last time by touching that slug? That's not going to happen this time. All right. You know what? I should have done this in order. I'm going to go ahead and do some heterodyne oscillator voltage checks just to see if we don't have a dead band. Okay, I'm checking DC voltage. I've got my negative probe grounded to chassis, and my positive is at the test point, and if you flip it around, you'll see on the board it says TP right there. I like to do it from this side so that I have access to my coils. And I know right away we've got a problem. Let me adjust the coil and see if I can't get some voltage to wake up here. I'm going to be turning this and watching this, hoping this will give me like a -1, -2. Right now it's at -0.0215. I think this band is dead. Yeah, see, I've got that slug all the way out. So what does that mean? That means 99% chance this band crystal has drifted and it's no longer viable. So that means I have to abandon the alignment and get a new crystal installed. This is the crystal switchboard, and this is one that I pulled from another rig just so I could use it for reference. The 21 megahertz crystal is right there, and that is a 29.895 crystal. So let's go through the crystal collection and hope I got one. All right, that 21 megahertz crystal wants to come out. How do we do it? You don't have to take this board out. You just need a good soldering iron with a long tip, and you just heat up one side, walk it out a little bit, heat up the other side. I don't know if you can see this because of my damn hand. Walk it out, come back, heat this side up, walk it out, and then there you go. This is my replacement. It's got a question mark because I wasn't sure if it worked. I think I pulled it from another rig, but we're going to try it. If it doesn't work, I'll have to go back to my collection. So heat it up again. Now I want to do a good soldering job. That's not a good job. That was just something to get it in there. So I'm going to flip the rig this way on its face and solder those two pins, and I'll be right back. We're wired back up. I'm going to go into the test point. And look at that. That's what we wanted to see. That crystal is alive and well. So knowing that, this is a good time to just go through and check every band. Make sure we've got some negative voltage. And I mean like -1, -2, even -0.8. But if it's like -0.02 or something, that's not voltage. All right, there's 40 meters, 20 meters, 15, 10, 10, 10, 10. All bands are good. Look how nicely that coil cover cleaned up with a little acetone. Okay, where were we in our alignment process? We had tried to get a calibrator tone at 21 megahertz. And remember, if you hear the same tone across all bands, that's just a harmonic. That's not the real calibrator tone. All right, so I'm on 21 megahertz. Oh yeah, that's what we want. Okay, so now we can peak it. Oh man, there's another stuck slug. Oh no, here it goes. Remember that pre-selector needs to be right on that mark. Okay. Okay, peak both coils. If you see the slug sticking out like that, you see that? That slug should be way down into the tube of the coil. So it has two settings. I'm going to take it down and get another peak right there. Okay, 21 megahertz is peaked. Now we go to 14. Pre-selector goes back to 12 o'clock. Okay. There's that slug sticking out again. In fact, they're all too close. These slugs are all at the wrong position, damn it. They need to be inside the coil, not out at the edge. So let's just screw it in there. We're going to lose peak, but then it's going to come back. There we go. That's where we want to be. All right. All right. 7.0. Leave the pre-selector where it is. Find your calibrator tone. Now we go here. Okay, this slug is where it needs to be. So let's just peak it. Okay. Okay. Terrific. So that is pretty much the alignment of the receiver in total. We're going to move on to the transmitter alignment in a bit. That part of the process with one of these restorations always gives me pause, because now I find out if the thing has any output or not, and that's always a little scary, because if it doesn't have any, oh boy, troubleshooting the transmitter is a pain. But why don't we see if we have output? All right, I am into a dummy load. I'm using one of these. It's a dummy load with a meter. It's very long and it handles a lot of output. I love that guy. All right, so I'm on 80 meters. Got my level up. I'm at the 12 o'clock position. And now comes the moment of truth. And I've got no output. Damn it. I was afraid of that. Okay, let's try another band. Maybe there's just some fluke on 80. I don't know. Let's see. Let's go to 40. We got no output on 40. Oh boy. Well, that sucks. Okay, if it's not working in tune, let's make sure it's not working all the way around, because sometimes you don't get any output when you're in tune or CW, but you've got sideband output. So let's see. Test 1, 2, 1, 2, 1, 2. Okay. We've got sideband output. That's good. Our transmitter's working. It's a problem with the tune position. Let's see if it does the same in CW. Nope. Well, that's not surprising, because CW and tune are kind of married. I know what I'm going to check, but I'm not going to check it tonight. It's late. It's 10:30. I'm tired. And I don't like to work when I'm tired. I'd rather have a beer and chill and start over in the morning. So let's do that. So whenever there's a problem transmitting in one particular mode, or when one particular mode sounds kind of garbled, like if the LSB sounds bad but the USB is okay, it could be one of these three crystals. So that's Y1, USB, LSB, and CW. To test the crystals, it's pretty easy, but you need a frequency counter. I'm going to put my frequency counter on the center pin of the carrier null. That's the one we installed on the bottom. And by the way, how do you know what the frequency of those crystals should be? It's right here in the circuit description. Now this is an HW101 manual, but it's the same. And you can see there's your CW crystal, 3395.4, your LSB 3393.6, and USB 3396.4. When I connect it to the center pin, my frequency is 3396.4. That's what it should read in USB receive. That's okay. When I go key down, I'm getting 33954. That's what it should be. When I go to tune, 33954. So, yeah, that is telling me my crystals are just fine. There's a problem somewhere else. Here's another problem. I don't think these are related, although they might be. I'm going to go key down. Listen to the audio when I let go of the key. I have to clear it to get the audio back. It does it every single time. So something's going on. I think that there's a intermittent contact here somewhere, and it's because of the contacts getting crusty. To get this out, however, I had to remove the final tuning shaft, this guy. I had to pull that crystal, I had to pull 3 capacitors, and oh man, I just hate dealing with mode switches. You know why? These phenolic wafers are super fragile. It's so easy to break these. I've done it before, and I just hate having to wire in a new mode switch. I really hate it. So I'm going to take this out as much as I can and look at where I've got contacts when I'm in the CW mode. And I'm going to go in there and scrape those contacts a bit and keep flooding it with contact cleaner. The thing is, you can't just turn the rig on and test it because you pulled all those components. So you've got to just do a good job, put it all back together and hope for the best. And you may have to pull it again. Well, got everything put back together again. And I think that must have fixed the problem. And now, guess what? We have output. So I have started the transmit phase of the alignment. That transformer right there, I peaked it on 80 meters. And then I went back to these driver grid and plate coils, and I put it in tune. And I went through the entire process again, making sure the driver pre-selector was at the correct location. I did the whole alignment again, but I did it in tune. So instead of listening to the calibrator, I was watching my meter. And that way I know for sure those coils are tweaked right where they need to be. Let me show you something else that's extremely important. We're going to adjust the bias, and if you're used to the Heathkit HW101, that's on this rail right here. Well, on the SB rigs, it's all right here, and your bias is the one in the middle. I see that the person who built this rig marked them. So there's your bias. We're going to key the mic, and hold it, and then watching the meter, I'm going to put my screwdriver in there and bring that down so that it's on the 50 milliamps. That's right there. On the HW101, there's a little triangle showing you where you need to be. On this one, it's halfway to the 100 mark. By the way, just a word about reading the meter. If you go into the high voltage selection, and you're there, you're looking at the 8. That's 800 volts. If you're on plate, and you key the mic, you're looking at 50 milliamps. So top row, 2, 4, 6, 8, 10, that's hundreds of volts DC. Second row, 100, 200, 300, 400, 500. Those are milliamps. And by the way, check your bias often. That bias can go off, and that's going to affect your RF output, and it's going to damage your tubes if the bias is too high or too low. And if you're, for instance, if you're just getting a rig that you've never owned before, that rig needs to sync with your power supply bias voltage, and those are not always exactly the same. In fact, they're often very different. So always check your bias. Put it on plate, key the mic, or short pin 2 to chassis, and just adjust the control. Super easy. Time now to neutralize the finals, a very important stage in the alignment process. There's two ways to do it. The manual will describe a way that's kind of easy but not terribly accurate, and then the service bulletins give you a more difficult way that's super accurate, and that's how we're going to do it. I'm going to start out by pulling this tube, desolder the high voltage at the base of the RF choke. Okay. I desoldered the high voltage and wrapped it in electrical tape. You do not want that touching anything. That's 800 volts. Put this tube back in place with the parasitic choke on top. Next, you want to remove the screen grid voltage, which is this 100 ohm resistor right here. I'm just going to desolder it from this rail. Just going to leave that hanging in space for a moment, like that. This is a homemade RF probe, and I've got it going to the center pin of the antenna socket. Okay, got that in place, grounding it to chassis. Oops, come on, get in there. The rig is off, by the way, that's very important. So we're running this through an old school vacuum tube voltmeter, the kind that has the 1/4 inch input, and got it set for negative DC voltage. All right, you can do this with an oscilloscope. I find watching the movement of a needle a lot more easy to visualize than watching the jumpy numbers on an oscilloscope, but it's up to you. If you don't have one of these, then you'll need a scope, but you need one or the other. Did I mention that doing these restorations takes a lot of various test equipment? It also takes a good soldering station. I recommend the Hakko. This is the 888D. I've been using this for years. I've done so many restorations with this guy. He needs a new tip. I just ordered some, and I'm really wearing it out. But I've probably restored 50 rigs with this thing so far, and it's never given me any problems. You can get these for like $75 on eBay used. So anyway, Hakko does not pay me to say that, but I love it. All right. I'm going to turn on the rig. We're going to go to 28.5. And let's see. What else do we need to do? Let's wait for it to warm up. Let's get this. We want to make sure that we are tuned for 28.5. I'm going to get a peek on the pre-selector. Get this roughly where it needs to be for 28.5. Okay, put it in tune, and I'm gonna just try to peak it, go for maximum voltage, RF voltage, which is, it's very low voltage. We're on the 1.5 scale, so this is very low. Okay, that's what we got. How do we bring that as close to zero as possible? This is the neutralizing capacitor right here. I've got my screwdriver ready. All right, put the rig in tune. Now I'm just going to adjust that screw until we've got this right down to zero. And that's all there is to it. Time now to null the carrier. I've got the high voltage reconnected, the screen grid voltage reconnected. I've got the RF probe back in place. So we're running full power again. And I've got the level at its fully counterclockwise position. We're on 80 meters. Let's see, lower sideband. I already peaked the finals. What I'm going to do now is, with the level fully counterclockwise, I'm going to key the mic and see if I've got any reading. Oh yeah, oh boy, we've got some carrier. All right, so let's just take this up, key the mic. All right, so there's that 20 turn pot, if you remember, and it needs to be adjusted. All right, so I'm going to get my screwdriver ready, and then I'm going to key the mic, and I'm going to adjust this to try to get a minimum reading on the meter. All right, let's try to get this as low as it'll go. And that's it. Got the rig back on its side. Keep in mind, normally you would be doing this all from the top. You would have a carrier null pot there. And then you see that capacitor right there. That's a secondary fine-tuning adjustment. So I'm going to do the same thing. I'm going to adjust that one. Okay, I've keyed the mic. All right, and that's as low as it's going to go. I feel like it needs to go lower. Well, I gave up on that 20 turn pot. I went ahead and installed a replacement standard 200 ohm potentiometer. It's very much like the one that was originally on there. This is just a new old stock. So let's see if we can get this thing to null. Okay, I'm on the lowest voltage setting, and I'm going to adjust the pot while I key the mic. Oh yeah, oh wow, good. All right, now go back to that fine-tune capacitor right there. We'll key the mic, and that's as low as we're going to go. That's little over 0.1 volts. So yeah, I think we're good. It's the next day. I must be getting close to being finished because I put my sticker on it. That's usually a sign of optimism. Clean my workspace. Man, what a difference. And today, for the next hour or so, I'm going to have some QSOs and see if I don't detect any other anomalies. Sometimes these things only show up after a little bit of break-in time, so I'm going to go ahead and just play with it. As far as the transmitter alignment, I didn't cover the adjustment of the heterodyne oscillator coils, but basically that is covered right after you tweak the driver grid and plate coils. And I am doing this a little bit out of order from the manual, but remember when we tweaked these while we were in tune? So I went through and also peaked the heterodyne oscillator coils. And keep in mind, there are 3 of them on the top of the board. There's 14, 3.5, and 28.5. So yeah, those need to be peaked. Right now, it's looking like I've got full output all around. Hey, this is November 5, Oscar Lima Alpha, N5 OLA, over.
N5, was that OLA, Oscar Lima Alpha, is that it?
Roger, roger.
Okay, good evening to you. You're flying 9 into Arkansas, N5 OLA. I gotta write this down. Kilo Whiskey 5 Hotel Papa returning. You're good 5'9" into Little Rock, over.
Roger that. You're a strong 5'9", maybe even 10 over. We're the southern tip of Texas. Name is Will, Whiskey India Lima Lima, over.
Okay, Will, I know exactly where South Padre Island is. It's been many years since I was there. My son and my daughter, we went vacationing there, I guess back in the mid-90s.
So I'm running a Heathkit SB-102. I just restored it. It's putting out a good 100 watts tonight into a vertical antenna. You're my first sideband QSO with this SB-102 from, I guess, around 1970, 72, over.
Yeah, okay, well, it sounds great, Will. It sounds great. You know, I've been looking for one of those. I knew a guy, RTO Electronic. He had an SB-102 and an SB-101. And when I got in contact with him, man, those things sold so quick it was pitiful to go in my SB-200. But it sounds great.
Found a really nice cabinet for this rig. Really nice. It does have a little bit of scuffing here and there, so I'm going to take care of that with some of my SB series brush bottle touch-up paint, which I do sell on eBay. I don't like to use this so much on the HW rigs. When you apply it to a solid color, it's really hard to get a perfect match on that. When you apply it to this sort of mesh, and when it dries, you'll have a hard time seeing it. Like right now it's wet, so it's pretty obvious. But when it dries, it's gonna look pretty good. So yeah, just a little bit of scuffing. But nice feet. I found those on Amazon of all damn places. I'm glad, because I've had a hard time tracking down some feet that were a perfect match. I finally found them. So yeah, I'm gonna just kind of look for little places where I can do a little touching up. The details do matter.
It required some major renovation, so I do have a detached camshaft, and I think I need to go back in the house and get dressed.
There it is. What a beauty. What a labor of love. Was it worth it? Hell yeah. But yeah, lots of steps involved. If you are attempting a restoration, you're going to hit some quicksand, and just expect it. It's these things it's a Gordian knot to try to unravel. But there are some good online forums. There's a Heathkit Radio's IO forum. A lot of expertise there. That's where I learned this stuff. There's also a Facebook group, Heathkit Owners Group. That's a good one. I think the IO forum has more of the technical expertise you might be looking for. So, hey, don't despair. Just keep on plugging along. One problem at a time. You'll work it out. Take care, and good luck on your restoration. This is N50LA.